Hello, everybody. In Algebra 2, we're not having class obviously this week in person, so welcome to our virtual class. Before we get started, I just want to mention and just make sure that you're aware that Friday, we have a tutoring session available. Okay, so it's Friday, and I guess we put it here, so it's Friday, and since this Friday it's February 4th, and it's from 12:45 to 2 p.m. on Zoom. Okay, so if you don't have the link, go ahead and email me, or have your parents email me, or get the link from your parents. Your parents should have the link. Just come with any questions you have. If you have any questions about the exams, I think just save those for the following week. It'll be easier to address them when we have your exams in person and everything. So we'll talk about those. And yeah, so that's all I have to say about the tutoring this week. And you can always email me with questions you have. Some of you guys do. So I actually do appreciate that. It's helping you and it's helping me teach you guys better. So anyway, so without any other things to say, let's go ahead and move on to our lessons here. So as we always do, we're going to start with our supplement. So our supplement here is week 19. Right, so let's write week 19 up here. And in the previous weeks, we always were factoring quadratic trinomials when a was equal to 1. Okay, so if we think of second, something on my screen here. Here's my little thing here. Go back here. Okay, so we have trinomials, or sometimes this x squared plus px plus c. Okay, so this is, again, the topic is factoring trinomials. And in most of our cases, a that you see here on the left here was equal to 1. For this week, you can write factoring trinomials, and this is a is not equal to 1, okay? So this is a little bit different than what we're used to, but we'll talk about that. So you probably remember we're factoring by grouping in the last couple lessons here. So we had several terms here. So let's go and talk about this. Okay, so if we have, in our example here, we had 3x squared minus x minus 2. Usually we're thinking about factoring it by making our a equal to 1, right? So our a in this case is equal to 3, right? So if I underline this thing, right, that's a. And then b we would know would be minus 1, and then c would be minus 2. So that's typically how we'd write it, or we would divide by a. But in this case, we're just going to set up our normal chart like we always do, right? So we're going to set up our MTAT chart. So our MTAT chart here, right, is a times c. So a times c in this case is minus 6, right? So see if I have enough room to write this. I'll write it on this side, okay? Minus 6. Then b is just equal to minus 1, okay? We still set it up the same way, and we still find two numbers. So two numbers that multiply to minus 6 and add to minus 1, right? So that's, I remembered our MTAT. And if we think of moving left to right, then we multiply 2, and that's A and C, and B, right? So A, C, B. So we can think of plenty of numbers that multiply to minus 6, right? So if we had minus 6 and positive 1, but those don't add to minus 1, right? But then if we think of 3 and we're going to multiply it by minus 2, that's pretty close, right? But if we do 3 and minus 2, then we end up with positive 1, right? So then we'd have to think about it one more time. So minus 3 and positive 2, right? So that'd be minus 6. And it'd also check off our box over here. So minus 3 and 2. So we can think of this right here. Actually, go back and I'm going to highlight this in red. We can think of this right here as being term 1. I'll write it like this. So term number 1 plus term number 2 when a is not equal to 1. Okay, so term 1 and term number 2. So then when we rewrite this here, we still write 3x squared, but then when we're going to this next part right here, we would write it like this. We write minus 3x. Okay, so 3 is our number over here, right? So our number minus 3 and positive 2, so it would be minus 3, and we have plus 2x. And then for this last part, right, it goes back to the normal, so we just have minus 2. Okay, so then at this point, we can factor by grouping, right? So let me see if I can get this thing out of our way here. So at this point, our step would be to factor by grouping. Oops, not fractions. Factor. Okay, so factor by grouping. Okay. So I guess if you're going to go back and look at our steps here, and I just label them, right? Our first step here really is to set up our ABC chart. So that's really our number 1 over here. There's our chart. And then we're going to then write it out, right? So that's our number 2 here. And then 3 is our factor by grouping. I think that, yeah, so your paper that you guys have breaks down a little bit differently, but that's the steps I like to think of. I think of like 1 is setting up my chart, 2 is writing them out, 3, and then I'm going to factor them by grouping. Okay, so if I go back here and I factor them out, these first 2, right, I can see that 3 is common. So I'll factor 3 in my x, right? So 3x, and I'll factor out here, x minus 1, right? And then for this next part, I can write plus, and then I can factor out 2, right? So 2's here, 2's here. Then I write plus 2, and then I have x minus 1, right? So this is, if I had some more space here, and I could write it all out here, but you guys can see, so if I divide up into my groups here, right, I can see that this x minus 1 factors out of both of these, right? And then I have over here, by right here, I just have 3x plus 2, right? So then, if I was going to write it on my next page, so let's, whoops, let's go ahead and do my next one here. And then we can look back real quick. And I'd write 3x plus 2, so that's what I had over there. And then I'd have x minus 1. Okay, so let's go back and make sure that's what I had here. So let's see. If I go back here, it looks like that's what I had, right? So I had 3x plus 2 and then x minus 1 for both of those. So that's what I got. So now if I want to double check my answer, right, then I'm going to go ahead and do my FOIL method, right? So first times first, oops, this doesn't show up very well. First times first, and then first times or outside by outside, and then I do my inside by inside, and then I do my last and last, right? So that's the FOIL method. So if you forgot the FOIL method, go ahead and you can look up FOIL method, right? So then if I go ahead and do this, then I should end up exactly with what I began with, right? So then I'll have 3x squared if I multiply that first term right there, so 3x and x here. And then I'll have minus 3x, and then I'll have plus 2x, and I'll have minus 2. Okay, so that's exactly what I ended up there. And then you can see if I add these two together here, then I'll have minus x minus 2, and then I have 3x squared. Okay, so that's what I started with on the chart there. Okay, and then I don't know that I'm gonna belabor this too much, but maybe we can go ahead and real quick think about this second one here. So if we go back to this second example here, right? We have 10x squared plus 13x minus 3. And so then our first step, right? First step, write my chart. Okay, so write my chart. So A times C, or I can think of, right, it's my MTAT. Multiply it as 2. So MTAT here, A times C, so 10 times minus 3. So I have minus 30. Right, minus 30 correctly, right? And then I have 13 here. Okay, and then it just takes a little bit of time thinking about these, right? Because I could think of, okay, well, 10 minus 10 and positive 3, right? I can multiply those together. But then if I had minus 10 plus 3, that wouldn't work out, so that's not going to work. Another factor of minus 3, right? So I think of minus 15 and positive 3. Right, so that actually would work for this first one, and it doesn't work for the second one, sorry. Right, because that'd be minus 13, plus 13. So then just shift it around, right? So 15 and multiply it by minus 3, and that does work. Okay. So these two don't work, that one works. So then again, it's my middle term here, the b term, right? So then I'd write 10x squared, and then I'd write 3. See what I'm doing here? I'm going to write 3. Right, so this is 2. This is 2. Sorry about that. And so then I can write minus plus 15x minus 2x minus 3. Okay, so that's how this thing broke down, right? This is my b term. If I add those together, then I get 13x. All right, so the tricky part of factoring by grouping here is thinking of which two terms you can factor things out, right? So if you go back here, we can see that we can factor 10 out of this number. We can't factor 10 out of this second number here, right? And we can't factor 10 out of anything else right here. So then we've got to think about this a little more creatively, right? So we could factor 5 out of this 10. We'd factor 5 out of this one right here, right? But then when we're talking about factoring these last two terms here, we can't factor something really common out of both of these. So instead, I'm going to group them like this. I'm going to put this, whoops, go back here. I'm going to try to highlight the colors here so you see. Right, so my 10x squared here, I can combine it with my minus 2x, right? So there's something common there. And then my minus 3 has a common factor of 3 with 15x as well. So then instead, I'm going to think of it this way. I don't have to rewrite it necessarily, but I can write like this, and then I can write plus 15x minus 3. Okay, now I can see that these two go together and these two go together. So then I'll write not 10, oops, 2, right? So 2x will factor out of factor out of both of these. And I'll have 2x, and I'll have 5x minus 1, and then I'll have plus, and then factor 3 out of this one. So I'll have 3, and then I'll have 5x minus 1. Let's see, this is 1 right here. Okay, so, oops, back here, make that marking board there. Okay, so then if I was to factor this, then I can go ahead and write equals, and you can see 5x minus 1 is common to both of these, and then 2x plus 3. So then I'd have 2x plus 3, and because I ran out of space, I'll just write it like this, and then this is times, right? Times, and I have 5x minus 1. That's how I'd factor that one out. Okay, and it doesn't matter what order you do them, right? Because multiplication doesn't care which way you multiply it. If you multiply it left to right, right to left. Okay, so that's it for our supplement. So go ahead and practice those. You can pause this video. I'm going to go on to lesson 68 after this. So you can pause it, or you can just go ahead and go on to the next one. Okay, so here's lesson 68 here. We'll go back to blue. Okay, so lesson 68. Alright, so this is scientific notation. So, oops. Just tell me the lesson here. Okay, so done. I don't know. It's giving me more trouble here. Let me see. Can I just go back to here? I don't want the thing to show up. Okay, here. That's a little bit better. Okay, so scientific notation. Okay, so not everybody likes scientific notation, but it is widely used in the science world. That's important. And then we also have powers and roots. Okay, so there's our two topics there. So we have powers and roots and scientific notation. So the book says to estimate for a lot of these. I don't know that I'd say that you have to estimate these, but you want to make sure you know how to use your calculator, okay? So for example 1, let's write that out. So we had example 1, it was written that we had minus 40,652 times 10 to the minus 4. And then we're going to multiply it by, and so, yeah, I'm going to run out of room here. 0 point, and there's 3 zeros, so 0, 0, 0, and then 324 times 10 to the minus 11, or 10 times 10 to the, actually it's positive 11. Okay, so positive 11. So if I'm going to rewrite this in a more understandable form, I'll just write minus 4, and then I'll write 0.0652, and change anything here. And then if I want to move my exponent here for the 10, If I move the decimal to the left, right, I'm going to have to multiply them back out, right? So my decimal place originally was after the 2 here, so I'd have to move it 1, 2, 3, 4. I'd have to move it 4 decimal places. So then if I expand it out, then I'm going to have to add 4 to this. So then my exponent here becomes 0, which, you know, anything to the 0 is just 1. But we'll keep it like that for now. Okay, and then if I do this one, I'm going to have to move the decimal places right here between the two first zeros. I'm going to move it 1, 2, 3, 4. Right, so I'm going to move it 4 as well, but I'm moving in the other direction. 3 to 4, and then times 10, and then since I move the other direction, right, then I'm going to have 10 to the 7 here. Okay, so then if I want to estimate, for example, just to give you guys a little idea here, because most of the time you maybe not going to estimate, but I'm telling you to estimate here, right? And they told us to. Then we might just write, okay, well, let's write -4, and we'll write times 10 to the 0, which is just 1, right? This little part right here, that's just equal to 1. But we'll keep it there nonetheless. And then this is multiplied, and we'll say it's 3 times 10 to the 7. Okay, and then I'm going to write it here. Okay, so if you just multiply -4 and 3, what do you get? Right, you get -12. Okay, so you get -12. And then if you add the exponents right here, right, this first one is 10 to the 0, and the second one is 10 to the 7. So you'd simply have -12 times 10, and you'd have times 10 to the 7. Okay, so that would be the estimate there. And then if you do it on your calculators, you get what you have in the book, which is going to be very close to this. I think it's 1.34. I don't have the book open to that exact page right now, but anyway, that's what that will be. Okay, but that's a good first estimate there, and that's how you get to it. Okay, so let's go to power and roots example real quick. Okay, so if we had an example 3, okay, so this is still less than 68. So example 3, we have 50.42 in this radical here. So 50.42. So this thing's all the way over it. And sometimes people put this little notch here, just to make it clear that it's over something. So you can use that or not, but that's sometimes how I write it. And then you have 3.28 here. Even sorry, very readable, but 3.28. So we learned before, right, normal square root, you have a 2 in this corner right here, right, where I'm underlining this. So that means that it's just a square root, right? So this one you would not call, I don't know, even a cube root, right? Because a cube root would have a 3 in this corner. But the way you'd note this when you write it out again is you write the number that you have in your square root radical part, and then you can raise it. So in the typical square root, you're raising it to the 1 over 2. Okay, so in this one, you're raising it to the 1 over 3.28. Okay, so if you're raising to 1 over 3.28, and I'm going to go ahead and go here and make sure I have the right value to write here. But you guys should try this on your calculator and make sure you can get it. Okay, so when you do this, you should get 3.304 on your calculator. Okay, so the important thing is that when you do this in your calculator, you raise it, it's probably that you have parentheses around this or something like that, okay? And then this last example here, or at least the one that I want to highlight here. So if we have example 4, and we have 9.26, right? You need to go ahead and understand how to raise to power. So there's probably like a shortcut. There will be a shortcut on your calculator that you have. So you're going to go ahead and do that one. And then that's part A. Okay. That one's pretty straightforward. But then if you have part B here, you can plug this one in a variety of ways. I think you can probably just go ahead and plug it in with this minus 4.58 here. That'll work. But we learned before that you can flip it over the denominator. Okay, so instead you can think of it as 1 over, and then it'd be 9.28 raised to the 4.58. 58. Okay, so that's the other way to put it into your calculator, right? You calculate this thing on the bottom, so 9.8 raised to 4.58, and then you take 1 and you divide it by that number. Okay, and I think that's all I want to say about lesson 68. Like I said, you can pause the video now, work on the practice problems that you have there. Make sure you get the right answers in the back of the book, and then you can move on to lesson 69. So I'm just going to go ahead and move on to lesson 69 here. Okay, so for lesson 69, we're going back to the gas law stuff. Okay, so there's anything else in here? No, there's just gas law problems. Okay. Gas law. It's gas law. So we have this. If you don't have this memorized, put it on like a note card, right? We have P1 V1 over T1 is equal to just the same thing on the other side. P2 V2 over T2. Okay. So pretty simple, right? And then if you need to get anything here, right, then you just cross multiply and you can get to that, right? So in example 2, they want to know what our P2 is, right? So they ask for P2, right? So that's our question. So if we cross multiply this stuff above here, right, then we'll get P1 V1 T2 is equal to P2 V2 T1. Okay, so then in order to get P2, then we're just going to divide by V2 over V2 T1, right? V2 T1 on both sides, and then we'll have P2. So then we'll have P2, and like I said, I'm running out of room over here. But then you have P2 is equal to P1 V1 2, oops, over V2 T1. Right, so you guys can see that. Maybe not as well as you'd like to because I messed that one up. Okay, but P1 V1 T2 over V2 T1. Okay, so then they gave us some things to plug in. So if we go ahead and do that, right, the first, so this is still example 2, they gave us the P1 and they gave us that 0.003 times 10 to the 14. And then we can include the units, but I think I'm going to not do it because of space here. But it is important that we make sure that our units are in degree. So 0.007, and then our last one is 0.003, and then it's times 10 raised to the 7, and this is Kelvin. Okay, so that's P1 V1, and then T2. Nice, then if I divide it by what they gave me, I have 3 times 10 to the 2 for the volume, and then I have 7,000 Kelvin. I read that unit right. Kelvin for the temperature 1. So now if I'm going to simplify this, right, for this first one, I can move the decimal place over here to the 3. So I have to move it over 3 places. And it's making the number smaller, right? Because if I want to change it back, right, so then this will be times 10 to the 11. And this other one, I'm going to do the same exact thing, right? So I'll have 7 times 10 to the minus 3. And then for this other one, I'll have 3 times 10 to the 4. And then for the bottom, one of these terms doesn't change at all. I'll have 3 times 10 to the 2 for the volume. And then for the Kelvin, I'll have 7 times 10 to the 3 for Kelvin. And I guess what I should say is that I really probably should keep this significant digit over here because I think there's 2 significant digits given for everything. But anyway, if you do this right, we could actually estimate the problem. Great. 3 times 7, that'd be 21 times 3. 21 times 3 would be 63. Right, so we could have 63 on the top, and then 10, 11. So if we add our exponents, we have 11 minus 3, so that'd be 8, 4, 12. Right, so then we have 63 times 10 to just say 12. Yeah, times 10 to 12. And then on the bottom, we'd have 3 times 7, so that'd be 21. And then we'd have times 10 to the 5. So actually, their estimate and what we are going to get are going to be exactly the same thing, right? So we do 63 divided by 21, we'll get 3. And then we do 10 twelfths divided by 10 sevenths, or 10 twelfths divided by 10 fifths, then we'll get times 10 to the 7. Okay, so then if we do that, then we'll just get times 10 to the 7. And what we're looking for pressure, right? So I think the pressure that they gave us was, what was it? It was pound inches squared, which if you don't know already, right, this right here, right, you always see PSI, right? This is pounds per square inch right here. And I guess I could go to my example 2 just to make sure I got it right. Yep, so 3 times 10 to the 7 pounds square inches there. So you can see that our estimate was the same exact thing as calculating it out. So anyway, that's it for lesson 69. Like I said, if you want to stop, go and do your practice problem and then play the video after you've done that. That's would not be a bad idea. But I'm going to go ahead and go to lesson 70 after this. Okay, so lesson 70. I almost canceled our recording here. So we'll go back to drawing here. So lesson 70, I'm glad it asked me. I want to continue recording. Lesson 70 here. So lesson 70, we're dealing with advanced abstract equations, and by that I just say, I don't know, you could say advanced fractions, I suppose, but I'd say just do advanced fractions, right? Because we don't know what the values of them are, so I just say advanced fractions. But if you see otherwise, you say right, abstract equations. Oh, I forgot the S. Abstract equations. So the only thing that I want to say here, you say if necessary, go ahead and distribute, right? So if we have anything to multiply, go ahead and distribute, right? That's a wise thing to do at first. So if necessary, distribute, and then multiply by LCD, or, right, so you can multiply by the LCD, or just say, or add fractions by finding LCDs. Okay, so you'll see how this works out, right? But I can multiply the whole equation by an LCD, or I can just add the fractions that are on either side by finding the LCD. Okay, so with that, let's go ahead and do our example here. So we have example 2 that I'm going to highlight here. So we'll see how much space I have on this one page here to do it. So we're told that we want to find C. Okay, so C is our goal here, and then we're given XP, not the operating system XP, but if you guys remember that on Windows, but M, and then we have B over 1 plus C, and we have plus A over P. Okay, so you can see this distribute part, right? So if I want to find C, C is only down here for the denominator of this equation over here, so it's kind of hard to figure out what to do with it, right? But we're going to distribute first. So we'll just have xp like we had before. We'll have mb multiplied here, right? Because this m is getting multiplied here, it's getting multiplied there. So if we had something more complicated, then we just gotta be careful about distributing properly to mb. And then this is over 1 plus c, and then we have plus ma over p. Okay, so you can see that I can add these fractions on this left side here, right? I can do that by making the denominator common, or I can look at all three of these, xp, mb over 1 plus c, and ma over p, and finding the LCD and multiplying the whole, all three terms by that, right? So if I look at my LCD, you guys probably see that it's p times 1 plus c, right? Sorry, LCD there. So if I go ahead and multiply it by LCD, right? So my LCD there. So if I multiply by P, 1 plus C. So in normal fractions, I do that because it'll get rid of the denominators. It'll make all the denominators 1, okay? So basically that's what's happening here. It just looks a little bit more complicated. Okay, but it's all pretty much the same. All the rules apply, everything like that. Okay, so now if we want to visualize this real quick, okay, our p times 1 plus c, this right here, it's getting multiplied by that term, and by this last term. Okay, oh, this doesn't look like it is right there. So I'm just going to start left to right. So I'm going to start with xp. So if I do xp, then I'll have xp squared, and I'll have, well, there's a 1, right? So let me, okay, times 1. And then, I'm not sure what, yeah. So x squared, and then, I think I will show it this way. So I'll do that, and then I'll just do 1 plus c, okay? And then I'll do equals, and then we have mb over 1 plus c. times p. Okay, does that make sense? Right? You can see my LCD right here is just I'm multiplying. It's just this little piece right here. Okay, hopefully you guys can see that. Okay, so back to blue. Okay, and then my last term here, I'm going to write plus. Oh, I guess change it back to blue, but anyway. And then this last one will have MA, and then it's times P1 plus C, so I'll have just MA times P, and then I'll just have 1 plus C. And then this is denominator is P. Okay, and then I don't know if I said the denominators cancel here, but let's go back to, we can go back to our notes that we had over here. So we had in this our notes right here. Um, let's see if this works out here. Add fraction by finding LCDs, and then if you still have room over there, and you say cancel denominators, and then the next step would just be to isolate and then to factor. Okay, so let's go back and see what that looks like over here. Okay, so we have over here is looks like a little complicated here, right? But if we're going to cancel our denominators, so let's put our thinking hats on real quick. I'm going to cancel with our green right here. Okay, so for this first term, right, we're all good. So we're going to say, okay, that's good. We don't need to do anything with that. We look at our second term here, right, our 1 plus c is cancel. So those cancel. Much the same way that our normal fractions do with numbers. And then over here, our p's cancel. So that works out really nicely. So then we'll go ahead and go back to blue, and we'll go ahead and see what we can do to isolate. Okay, so we have xp squared, right? So it's xp squared. Sorry guys, this 2 is giving me a little trouble. xp squared, and then we'll have plus xp squared c. And on this side, I don't have any c to deal with, right? So then this is just mbp, and then this one is plus ma plus MAC. Okay, so now we can identify that we have two terms that have C in them, right? So there's this one over here on the left side, right? This one has C in it. This one has C on it. So you can do this in a number of ways if you want to, right? If you want to see if this works out. Oh, I can move. Sweet. I didn't know I could do that. So let's try this out. So now I can go ahead and move this guy over there, right? Because he doesn't have C. So I'm going to move him over here. Let's say minus xp squared. I'm going to do that. So minus xp squared. Okay, so he's gone over here. He's gone. And then I want to move MAC over here. So I'm going to do minus MAC. So he's gone over there. But then I have to put him over here. Okay, now I have xp squared minus MAC. And then I have equals, and then I have MVP plus MA minus XP squared. Okay, so now our other step was to factor, right? So, whoops. You see what I did? I forgot to write the C here. So the C is there, right? Because we had XP squared. C minus MAC. Now I factor my C out. So factor my C out, if I factor C out of both P's, then I'd have simply XP squared, and then over this one I just have minus MA. Right, so you can see if I multiply these through, I get the same thing that I had in the first place. Then I can do MVP plus MA minus XP. Right, so a lot of writing back and forth. If you see what it is, you can certainly try to write it. It's just if you make a mistake, then it's your fault for making the mistake and not writing it out. Okay, so let's see if I give myself just a tiny bit more room here. So then I'm going to divide both sides by XP squared minus MA, right? So XP squared minus MA. So then my C, right, simply is equal to MVP plus MA minus XP over XP squared minus MA. Okay, and that's it. So really, it's not that many steps to do. I mean, I guess if you look back, it looks like I did a lot of work here. It's true, it does take a little bit of work here, and it takes more paper than anything. But the main thing is that we identify our LCD, right? So really our LCD we identified in the second step after we distribute it. I multiply it through, and then you can see with the green, right, then my denominators canceled. I distributed through again, figured out where my C's were, put them all on the same side, isolated them, and then I factored it out and then divided it. Okay, and then that's it for lesson 70. So if you want to pause for a second, work on lesson 70. Otherwise, we'll go on to lesson 71 after you click play again. Okay, so let's go to lesson 71. So lesson 71 here. Talk about the quadratic formula, okay? I guess I'll put that here, right? So quadratic formula. So you guys might be a little disappointed to know that we've been taking the square of things and factoring trinomials. But there's actually a really easy way to factor all these. Okay, so we've always started with ax squared plus bx plus c, right? And then we talk about situations where a is equal to 1, a is not equal to 1. Actually, it's equal to 0. So this is not always true. So this one has to be equal to 0. Okay, and then if that's true, then we can use this little handy dandy formula to figure it out. Okay, so we'd say it's equal to minus b, and we have plus or minus. So this plus minus right here means plus or minus, and then it's the square root of b squared minus 4 times a times c. Okay? And then all of this is divided by 2 times a, or 2a, right? You'll usually see it written as 2a. So that's how we can do it. So, you know, the first step really is, and I say solve, this solves any x squared equation that's equal to 0. Okay, so come in very handy. So let's go ahead and look at an example. Actually, let me go back here. Let's go back to here, and we open here, and then we'll scroll here. Okay, so we have minus b plus or minus b squared minus 4ac over 2a. So if I wrote here from example 1, example 1, then we have 3x squared minus 2x plus 5 is equal to 0. Right, the trick is to identify our a, b, c. Those are pretty easy, right? 3 minus 2, 5. Not hard, right? So then we can go ahead and write our little equation here. So minus b, so then this is just where you got to be careful. So it's minus b, so then it's minus 2, right? So minus 2, and we have plus or minus, and then we have the square root of b squared, right? So b squared is minus 2 squared, so that's going to be positive 4. That positive 4, and then it's minus 4 times a times c. So minus 4, and then a is 3, so 2 times 3, and then times c, so that's times 5. Okay, and our square root's all the way out here, and then this is all divided by 2 times a, right? So a is 3, so that's just going to be 6. So easy enough, right? Okay, and we can see it worked out, right? That's what we wrote. So now we'll go here and do a little more work here. So then we know this is going to be 2, and then it'll be plus or minus, and then the square root that we have here, we have 4, and then we have minus 4 times 3 is 12 times 5 is 60, right? So we have 4, whoops, I don't know what happened there, 4 minus 60, and then on the bottom we still have divided by 6, okay? And then if we continue from here, just because we have one term, we have 2 terms on the bottom, so that means each term is divided by this number on the denominator, right? So then we can just write 2 over 6. That would be the first term here. And then we write plus or minus, and then this is square root of 4 minus 60, so that's minus 56. And then it's all divided by 6. Okay. And then if we want to go one step further, just a little step at a time, I have 1/3, and we have plus or minus. If you remember, let's put it over here, right? I is equal to the square root of minus 1, right? So that means I can write plus I square root of 56. And I'll have this all over 6. Okay, so at this point, you could stop and you get most of the points for answering the question. But the thing is, here we could break square root of 56 into something simpler. So square root of 56, we could break down into square root of 4. So you think of perfect squares that go into this. So square root of 4, and we have square root of 14, right? Because 4 times 14 would work there, so then we'd have 2 square root of 14. Okay, so then for this answer here, we'd end up with 1/3 plus or minus I, oops, there's 2I, right? 2I square root of 14 over 6, or 1/3 plus or minus, and then see our 2 and our 6 here, right? So we have 2 and 6 here, so I'm just plus or minus, and then it'd be I square root of 14 over 3. And just like that. Okay, so I guess going back to the beginning of this lesson, this equation right here is the one that you should commit to memory, okay? And just takes a little bit of to bring it to my mind, right? So and it does come in handy depending on the application that you might have in a job later on. But most of the time, computers are calculating things for you. But you need to know how it works, right? So commit this one to memory here. Keep it on index card with all your other formulas. If you don't already have a card that has formulas in that index card, go ahead and get one and start writing relevant formulas that you want to remember on that. Okay, so I think that's it for this week. So, do the practice problems here, and then I guess I'll just say one more thing real quick, right? So remember that Friday we have tutoring, and you can come with questions, right? So don't just come and be like, oh, I want to see what other people's questions are. But if you get stuck on something, then I want you to tell me about it and come to the tutoring session from 12:45 to 2 p.m. So hopefully we're not, there's not so many questions that we're overwhelmed, but I'm sure if somebody else has a question, it'll be useful to you as well. Okay. So Friday 12:45 to 2. If you don't have the Zoom link already, ask me for it on email or get your parents to. All right. Talk to you guys later.